Hello and welcome to PreCalc. Today is Thursday, November the 5th, and our topic for today is even and odd functions. Great, we're going to dive in with some definitions. This problem down here will be our first example, but we're going to start with some definitions. Okay, an even function. We test whether or not a function is even by plugging in negative for x, and if you plug this in and the function stays the same, just still f of x, then great, it's even. So that's how we test for even functions. What an even function really means is that it has symmetry about the y-axis. For example, x squared is an even function because you can flip it over the y-axis. You can fold it about the y-axis. All right. How about odd functions? We test whether or not a function is odd by we still plug in negative for x, but this time the output needs to be the same as if you multiplied the whole function by -1. So notice here, for both even and odd, you start the test the same way. You plug in a negative x. Then, if the output is the same, f of x, it's even. If the output is negative f of x, then it's odd. And if the output is neither of those, then it is neither even nor odd. Okay. An odd function has symmetry about the origin. An example of an odd function is x cubed. And you can see that is symmetrical about the origin. Okay, let's dive into our first example here. For all of these, we want to determine whether it's even or odd and provide an explanation. So we're going to plug in negative x for all of these first. So now it's negative x cubed plus 4 times negative x. Negative x cubed is negative x cubed. Let me break that out for us. These two will give x squared, and now we have negative x cubed. Okay, and then 4 times negative x is negative 4x. Okay, I can see clearly this is not the same as just f of x. Let's test if it's odd. If it's negative f of x, we'll put a -1 out front. Oops. And we'll distribute it. Aha, these two are the same. F of negative x is negative f of x. Therefore, our function is odd. And our explanation will be odd because f of negative x is the same as negative f of x. Great, let's try another one. Pause wherever you need. Make sure that you're writing down the original problem. Alright, we're always going to start the same way. We're going to test f of negative x. So I've got negative x to the fourth minus 2 times negative x squared, and then 4 has no x, so it stays as plus 4. Okay. A negative to an even exponent is always positive. So this is x to the 4. This is still x squared plus 4. Aha! So this is the same as the original function. So our conclusion is it is even because f of negative x equals f of x. Great. Let's do another one. All right, we're going to call this example 3. Make sure you pause and write the original problem. We're always going to start the same way with f of negative x. So I've got negative x cubed. This minus on the outside stays. That's a part of the problem. Minus negative x squared plus 4 times negative x, and plus 2 has no x. Let's simplify. A negative number to an odd exponent is always negative. So this is negative x cubed minus negative to an even is positive, minus 4x plus 2. We get negative x cubed minus x squared minus 4x plus 2. Okay, that's definitely not the same as the original, so it's definitely not even. Let's see if it's odd. Let's see what negative f of x looks like. So I'm going to put a negative 1 on the outside, and then we'll distribute it outside of the original function. So I'm going to distribute to everybody, and I get negative x cubed plus x squared minus 4x minus 2. This has plus 2, this has minus 2. It's not the same as the original, it's not the same as negative f of x, therefore it is neither. So we say neither even nor odd because f of negative x does not equal f of x, and negative f, and f of negative x also does not equal negative f of x. So it must be neither. Okay, let's do another one. We're going to call this guy example 4. So we're always going to start the same way. Test f of negative x and see what happens. This negative on the outside is a part of the problem. We don't move it. And now I have negative x squared, and the 10 has no x, so it just stays as plus 10. So I've got negative x squared is x squared plus 10, negative x squared plus 10. Aha! This is the exact same as the original problem, therefore it is even. So we say even because f of negative x equals f of x. Alright, we got just one more here. We'll call this example 5. Make sure you pause and write the original problem. We're always going to start the same way. F of negative x. Negative on the outside stays. Now it's negative x cubed plus 5 times negative x minus 2. Any negative to an odd exponent stays negative. Minus 5x minus 2. Double negatives, positive x cubed. Alright, let's see. So this is not the same as the original, so it's definitely not even. Let's test if it's maybe odd. We're going to put a negative 1 on the outside of the original problem and distribute. So this becomes positive x cubed minus 5x plus 2. You'll notice the plus 2's don't match, so this one is neither. We say neither even nor odd because f of negative x definitely does not equal the original, and we tested negative f of x, and that's not true either. So in this case, it is neither. Alright guys, that's all for today. Thanks.